Notification is the last client data class that maps to an entity. In that sense, it will get more interesting after this point. The class is pretty standard. Again, these map directly to the client-side data. Notification might relate to a post or a comment, so having its ID here might be useful to launch said post when the notification is clicked. The constructor and DAO match the conversion of the other classes. The rest is again getters and setters. The next step is the DAO, which again maps very closely. There is literally nothing special here. We might as well have used the notification entity to some degree. As you can see, the rest of the code is classic boilerplate. This is getting a bit more interesting. Newsfeed represents the feed for the user. I could have just created a really complex join query on post and called it a day. But that's problematic. The newsfeed isn't just a list of posts based on date. It's something that includes a complex algorithm behind it. Running that algorithm every time the user pages through data might be very expensive. Furthermore, changes to the algorithm shouldn't impact past placements. We'd want consistency, and we'd also like to have a log of what did the user see. In that sense, constructing the newsfeed as an entity in its own right makes a lot of sense. We can place the articles into the newsfeed using a sort order that makes sense for a specific user without impacting everyone. We can tune and experiment with article placement algorithms easily because our processing can be done offline on the table itself. We use an auto-increment numeric ID since this object isn't exposed to the client side at any stage. The ID doesn't matter as much, and this ID type is faster. Every entry within the newsfeed has a user and post. Notice that the user is probably a different user from the one who submitted the post. Post day is the number of days since epoch. This is useful for sorting. I want today's posts to always come before yesterday's posts, even if they are higher quality. Timestamp is also used for the sort, but to a lesser degree. Rank can be manipulated by the ranking algorithm to push good posts up within the day. We have no DAO. We don't need it. This is a server-side object. We do need the getters setters though for the entity. The newsfeed also requires a CRUD repository class. We need to use the auth and not the ID to prevent a case where another user gets a peek at my feed, which might include friend-only posts. With that, we only have one more item. The shadow user is a potential user of whom we have knowledge, but he might not be in the social network. Do you ever wonder how Facebook seems to know so much about you before you even signed up? They keep suggesting people that they can't possibly know about. Well, here's one of the tricks they use. When you agree to synchronize your contacts to Facebook, and they nag a lot about this, they upload the whole thing and store it. If you have friends that are already in Facebook, you'll get suggestions instantly, but they keep everything anyway. When one of your contacts signs up for Facebook, they notice that you know and instantly add a suggestion. This works in reverse too. Someone has your email or phone number, so you'd see them as a suggestion. They go even further by associations. For instance, you might have a connection like that through a third party, so even if you never synchronized contacts, they'd still know. I chose to implement a relatively simple version of this and didn't include all the metadata that Facebook probably stores. This is mostly a simple proof of concept that should be enough for us to provide friend suggestions. We again use auto-increment for an internal entity. This is the metadata we gather for a user. There is obviously a lot more we can gather. This is the user who uploaded the data. So if the data in this record matches me, then I probably know the owner. We have a DAO object, but this DAO is write-only. So the entity isn't exposed to the outside world, but the outside world is exposed to the entity. That's why we don't have a getDAO method. We do have a special constructor type that makes adding a new shadow user easier. As with the other entities, the rest is just setters and getters. In a sense, the shadow user DAO is a bit different from other DAOs. This is pretty standard DAO with two big omissions, ID and owner, both of which are missing. The ID is redundant as it's auto-generated. The user is also redundant as it's always the user that uploaded the contacts. There is no point of including either one of those values in the DAO as they won't arrive through it from the client. The rest of the DAO is just getters and setters. In this case, the CRUD repository is actually pretty interesting. We need it for the case where we create a new user or update data. We need to find all the related users. Given a user's phone, we look through the database for users who might have that phone in their contacts. The same is true for email. We check if a user has uploaded contacts in the past by counting his entries. Assuming he has, we will try to merge the data. We use the full name of the user when merging contact data. With that, we finish the entities and we are finally ready to move up the food chain to the service layer.